Hi, class. We're going to talk a little bit here about some of the practical things of using textures, and it's kind of a grab bag of small things I think is really important to talk about. The first thing is to note that textures are rectangular. Just like most rasters we come across in a computer, texture graphics are rectangular. Now, shouldn't be a surprise, and it doesn't really cause any problems for us, except you realize that a lot of time what'll happen is, and by rectangular I mean they can be square and are commonly just square, but they don't have to be square. Any rectangle is fine, basically. Let's say I have a texture in here. What you'll see is you get all this wasted space around the edges. Unless what your texture is exactly square too, you get all that wasted space. So a common approach to this is kind of wasteful because graphics memory is often quite limited. So you'll see it's common to what we do is, I'm trying to spell that, we put other things in the texture. So it's common to pack several things tightly in one texture. So here you can imagine I come over here and, oh, in this space here I'm going to put some other object here and some other object here and some other shape here. And as long as when I use the texture, I set up my U's and V's to link into the S and T coordinate space appropriately, I'll map the correct region from the texture to my scene, okay? So I just use the U and V. Should put a tail on the U and V to select regions. Right, so you'll see textures kicking around with lots of extra bits kicking around, and that's why you see it that way. I will mention that mapping these complex textures to complex shapes when they get really hard. You know, the examples so far have been basically cubes, but when they get really complex, this is not really a computer science problem anymore. It's more best left to artists. To artists who are using specialized tools. That's not to say, or I'll rewrite that. That's not to say there's no place for computer scientists. Who makes the tools and who invents the new tools for the artists? They're computer scientists because you're the ones making the software, okay? So this is actually a really cool research area, is tools for enabling people interactively to create and modify graphical content. Interactive graphics, basically, is part of that. Another thing I'll mention as part of this is, you know, textures are flat, right? It's a 2D planar surface. So although most textures they're flat, they're two-dimensional, they're manifold surface. But we often don't think of them as being flat. Not really, if they're mapped onto a 3D surface. So you'll often see textures that look kind of funny, where, you know, you can imagine if I'm unwrapping a globe, I might have a section like this and a section, you know, like that or something. And that gets mapped onto a shape and it looks linear once it's on the shape. So we get a lot of different shapes and textures. It gets really complicated and you look at a texture and go, what the heck is that all about? But when you wrap it onto a 3D shape, and with all your STs and UVs set appropriately rather, UVs onto a shape, it looks nice, okay? And the last thing I'll mention in this little thread is textures can be stacked. So if you're texturing a surface, you don't need to just have one. You can have multiple textures on one surface. Okay, and you can use alpha blending to make it blend in and that kind of thing. So there's a lot of options here. Now I'm gonna go through a bunch of slides to show you some examples of what I've been talking about. But the main purpose of this section is so you understand what you're going to see in the real world and why you'd see those kinds of funky things. So let's look at slides 19 to 22. So here we go. So this is an example of what packed textures look like. So you see, let's see if I can pause it here. There we go. So this is a, oh, that didn't work. Okay, I'll do it again. This is a packed texture where you have a texture that's square, and some artist has filled it with all these all the pieces of a house. Here's the grass, here's the roof, here's the wooden bits. But then what they do is they use some software to map the U and T values onto this 3D model, so you're not wasting any space, and you have one texture for the house. And here's your house that's now nicely texture mapped, and all the pieces are in the right locations. Looks quite nice, right? So you do see this kind of packed texture very commonly in industry. Here's an example of what I meant by having these textures for 3D surfaces. This is a 2D texture, and again, here it's packed with an extra nose in there for something, and eyeballs maybe, I don't know, different pieces are in here. And you can see the mesh where it's mapped to, and it looks really funky, it looks really weird, but once it's mapped onto the face with the 3D shape, it actually looks quite nice. Okay, it's quite a nice texture map. And here's another example of that. You know, the texture looks really funky because it's an on-wrap 3D model. You map it onto the space, and here's the resulting image once you've wrapped that with UV coordinates onto this 3D model. As I said, this is actually quite challenging to get done right, and so it's best left to specialized tools and artists to create that content. The computer scientist's job is making sure it's rendered properly, helping to create tools, simplifying polygons, all the mathy type stuff underlying it. Now, I did have one more. Yeah, that's right. This is actually a rendered scene, at least according to their website, and it looks kind of rendered here, it looks kind of fake. But this is an example of a stacked texture. This table has a wood grain texture on it, but then they've put some paint stain texture on top of the wood grain. So there's two textures here. And then you can see here how the wood grain bleeds through the paint because they've put some blending into that. So that's all I really wanted to show with those things. And is just these examples of how textures are used in the real world. Now the last thing I'll mention before shifting gears a little bit is that textures themselves, I mentioned before, above they're flat, okay? But they're also typically sized in powers of 2. So they're you know, the sizes, their dimensions are powers of 2. Okay, so you can imagine the dimension could be 2 by 2 to the n by 2 to the m, let's say. A mistake people think is they read, oh, it has to be powers of 2, to think it must be square. That's not true. Each dimension must be a power of 2, okay? And I say often here, but on some systems they must be. And they used to be generally must be, but that constraint is becoming relaxed now as graphics cards are getting a lot more powerful. Okay, why were they limited to powers of 2? Well, first of all, it's a convenient byte boundary. Okay, if you remember from your system org classes, if things are aligned to the byte boundaries at certain powers of 2, they can use certain caching and certain acceleration techniques better in the hardware. If you're not matching the byte boundary, well, you probably learned about the word boundary, but same idea. If you're not matching those boundaries, it takes a bit more processing to filter that out. So it's faster if you can match those boundaries. It's also convenient for processing. Okay, so for example, if you have a texture that's a power of 2, let's say 1024, you can divide by 2 repeatedly to make it smaller. You can have it and have it and have it and have it again without any rounding errors, okay? So you can divide by 2, and there's no rounding, there's no odd case, nothing to worry about, it just works, okay? You also can do it very quickly with a bit shift. Right? I shift left or shift right to divide or multiply by 2. Okay? So that's really cool. Now, one last thing I want to talk about is I've been saying these textures are flat, but they don't need to be this way. Textures do not need to be two-dimensional. So textures in other dimensions. Sounds like a title from a 1980s horror movie. But basically, they don't need to be 2D. We've learned about 2D, so I won't talk about them. But they can also be one-dimensional. And a one-dimensional, or sometimes they're called array textures, sometimes people find these hard to get their head around. But all that you can imagine it as is I have a 1 by n texture. So you still have some height. It's not completely one-dimensional because there's a value you have at least 1 pixel. And you can put colors in here, you know. Whatever you want to put in here. You color your texture. So this is actually not that uncommon. It's useful for repeating patterns. Maybe I should say that a different way. Useful for patterns that are the same in one dimension. I'm not saying that very clearly, am I? So imagine a fence. You could have a one-dimensional texture like this, okay? And you can use that to scale up. So it's just like that. Maybe I should just use a slide instead of stop using words. And start using a slide and stop using words. So here's an example of one-dimensional textures. This is the fence I just mentioned, and it scales up nicely. So it changes in one dimension, the other dimension is fixed. Here's a one-dimensional texture. It's mapped this way, okay? It's mapped at an angle, and you spread it out. Here's a very similar one-dimensional texture. Again, you can map it up. So if you have this regular one-dimensional shape that's stretched out, you can use one-dimensional textures to do these things without taking a lot of memory. Okay, when you put them on angles and things, you can get some kind of effects too. You can imagine doing this and saving a lot of memory. Excuse me, just by just having the one-dimensional texture, as long as you can recognize this repeating pattern. Okay. That was a slide 20. Doesn't really matter. I guess you can find it. So if we can have two-dimensional textures and we can have one-dimensional textures, we can also have three-dimensional textures. And these are really kind of cool. Basically, it's a cube of voxels. Again, no, voxel is not a space enemy. Voxels are basically 3D pixels. Pixels have 2 dimensions, voxels are cubes, little cubes. So you have this 3D texture, and you can imagine it's, instead of being a flat texture, it's a cube texture. And you can imagine having, you know, like a 2D texture on top, but there's depth to it. Okay, so you have these cubes. Now, 3D textures are actually really, really cool. You can cut away. I should probably finish this. Right? You can cut away parts of the texture of the object. If I chop the corner off, I get cohesion inside. Assuming it's a proper texture, I cut the corner off, I can see inside of it, and I can texture the surface appropriately. So I can cut away and use a subset. For example, I can use a 3D texture of an apple, right? And then you can cut away a piece of the apple and you got it. Take out a chunk. See inside. It's also really good for perfect texture cohesion at seams. If I'm taking 2D textures and wrapping it around a 3D object, at some point I have a seam where they match up. And getting that to work just right is really tricky and sometimes impossible, and you gotta use little tricks to blend it and whatnot. If you have a 3D texture, and assuming the texture's already solved cohesion, you can put any surface inside that texture and it'll be cohesive. Imagine having a piece of wood, and this is a great way to think about it. A 3D texture is a block of wood, and I can carve any which way I want, and the grains are all going to line up. So let's look at a slide for that. So here's some 3D textures, and you see you have this 3D block texture, and they carve this out of it, and look at everything lines up just right, because within this shape, everything's cohesive. I can cut any which way that I want. Here's another 3D texture that's quite popular, coral, because you can see into it. The depth is real. Here's a 3D texture bunny using rocks, and then you can see as you cut away from the bunny, you can see inside the rocks, the pebbles, and you get this nice cohesion. So 3D textures are really fun. Here's the wood example I mentioned. This is made from a 3D texture, so you get this nice cohesion over the whole surface. In 2D, well, depending how you set up your UV coordinates, you might want to rotate this one, but you can't, right? Because if I rotate, then this one won't match. This one matches, but this one won't match. So it's really hard to get this cohesion with mapping with 2D. If I have a 3D texture, you can make it work really nicely. 3D textures are still really expensive, so you will see less of it in video games and graphic engines where they're important, but you'll see more of it in high-end graphic systems like movies and whatnot, where they can afford the extra bit of time. I'm not going to talk about it, but there's also 4D textures coming out, which is a cube, but the cube will change over another dimension. You could imagine having an age slider where it like a rotting piece of cheese or something, and it rots and it changes with age. Or you can have another slider to put density or whatever other variable you want. You can change it, and the whole thing changes. So this is really cool. All right, this is a good time to take a break. We'll come back and keep learning about texture mapping.